بسم الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضيات لغات، أهلا بكم. اليوم سنتناول الدرس الثاني في مادة الديناميكا بعنوان تكامل الدوال المتجهة Integration of Vector Function. Welcome my dear student in our math program for second 3. Today we are taking second lesson in dynamic is called or its title Integration of the Vector Function. My dear student, what about integration of vector function? The first lesson is called differentiation of the vector function. Second lesson, integration of the vector function. We know that we have two titles, integration and differentiation. Differentiation opposite what? Integration. We know that, my dear student, acceleration equal dv over dt. We find acceleration by using differentiation. If we have acceleration, how to find velocity? We make integration the acceleration respect to time t. My dear student, look at introduction about integration of vector function. My dear student, look at if we have t v vector or velocity time graph. Look at, my dear student, this is acceleration, represent line, straight line, start from t equals 0. In figure 1, in figure 2, we have vt, at is a curve. The graph down represents the velocity time graph and the acceleration time graph in one graphical figure. My dear student, the graph drawn represents the velocity time graph and the acceleration in one graph figure. Show that area under acceleration time graph during any time interval closed 0, 1 equals velocity of particle at time t. Definite integration. What you mean, my dear student, definite integration? If we have integration from a to b, f dash x dx equals f of v minus f of a. My dear student, if we have function and we find integration from interval a b closed, this is called definite integration. Definite integration f dash x respect to dx equals f of v minus f of a. After we find integration, we substitution about b at the first and about a in the second, then subtract f of v minus f of a is called definite integration. My dear student, look at important example. Integration of x squared plus 2x minus 1 inside bracket dx from 1 to 4. This is called definite integration. We know that in integration we add the power 1 and divided the new power. X square integration is x3 over 3. 2x equal 2x square over 2 minus 1 integration of constant is x. Therefore, answer is x power 3 over 3, 2x squared over 2 minus x from 1 to 4. Then integration becomes x3 over 3 plus x2 minus x from 1 to 4. This is definite integration from closed interval 1 to 4. Substitution about x equals 4, then substitution about x equals 1, then find the answer of the function. Answer is, my dear student, 64 over 3 plus 16 negative 4 minus 1 equals 1, third plus 1 negative 1. Answer is 33. My dear student, reducing the velocity and displacement. If we have, my dear student, acceleration equals differentiation of velocity respect to time t, then we deduce integration of acceleration respect to time t equals integration of velocity dv. Integration of dv means xv, therefore v equals integration of acceleration respect to time t. Note that, my dear student, different integration v naught to v dv equals what? X student. Integration from 0 to t acceleration dt. The left hand side is v minus v naught equals integration from 0 to t a delta t, or area under acceleration time graph. What you mean, my dear student? When find the value of the velocity and we have acceleration, we find area under acceleration time graph. This is change of the velocity v minus v naught. If the acceleration a is constant, what you deduce, my dear student? V minus v naught equals a is constant. Integration from 0 to t delta t or dt. Therefore, v equals v naught plus at. This is a first rule. V equal v naught plus at. My dear student, in this case, if we have acceleration and the required is velocity, we make integration of acceleration respect to time t. Why? Because we know that acceleration equals dv over dt. What you mean? If we have velocity and the required is acceleration, we know that, my dear student, acceleration is change of velocity respect to time t. But in this case, we have acceleration and the required is velocity. Velocity in this case, my dear student, equals what? Equals integration of acceleration respect to time t. My dear student, we know that if we have AV more than 0, what do you mean this acceleration, or mv more than 0? In this case, we have accelerated motion. We have no two acceleration motion, accelerated and decelerated motion. When AV more than 0, accelerated, less than 0, decelerated. And my dear student, if we have acceleration and the required velocity, we make definite integration from closed interval to acceleration respect to time t to find the velocity by using integration. My dear student, look at the another remarks. Look at, my dear student, remark. This equation can be used only when acceleration is constant, but the acceleration is a function of time. My dear student, this equation v equal v naught plus at can be used only when acceleration is constant, but acceleration is a function of time. If v, my dear student, equals dx over dt, what you mean? Velocity derivative of position vector respect to time t. What you deduce? We deduce that integration v dt equals what? Integration of dx. My dear student, by using cross multiplication, if we have v equal dx over dt, v dt equals dx. We use integration left hand side and right hand side, and we deduce that integration v dt equals integration of dx. What integration v dt, my dear student? X and student is x. What is x? Position vector equals what? Integration v dt. Then this relation is very important. Position vector x equals integration velocity respect to time t. Don't forget, my dear student, v equals dx over dt. Then x equal integration v respect to time t. My dear student, integration from x naught to x dx equals integration from 0 to t v dt. Therefore, we deduce that integration dx from x naught to x means x minus x naught equals what? Equals integration from 0 to t v dt. Note that x minus x naught is displacement s vector. If we have two position vector, x minus x naught is s or displacement equals area under velocity time graph. When we have graph or we have velocity time graph, area under the velocity time graph equals displacement x minus x naught or displacement s. My dear student, if the acceleration is constant, velocity v can be substituting from this equation. Look at when substitution v minus v naught equals acceleration, this constant integration o or from 0 to t dt. Therefore, x minus x naught equals, my dear student, integration from 0 to t v naught plus at delta t or dt. Therefore, my dear student, if we have integration v naught plus at delta t or dt, therefore v naught t plus half at square, therefore x equals x naught plus v naught t plus half dt square. If acceleration equals v dv over dx. Remember, my dear student, we have acceleration dv over dt or v dv over dx. Why? Because v equals dx over dt. My dear student, acceleration we can put dv over dt or v dv over dx. Therefore, by using cross multiplication and use integration, we know that integration a dx equals integration v dv. My dear student, we have second case of acceleration equals v dv over dx. By using cross multiplication, therefore a dx equal v dv, and use integration left hand side, right hand side, then we have equation, the first or left hand side integration a dx equals right hand side integration v dv. Therefore, my dear student, we deduce that v square equals v naught square plus 2a multiply bracket x contains x minus x naught. And we know that, my dear student, x minus x naught equals what? Excellent student, s, displacement. And by substitution about x minus x naught equal s, we deduce that the third law, v squared equal v naught squared plus 2as. My dear student, look at important example. A particle starts to move in a straight line from origin point with initial velocity of magnitude 8 meters per second. Particles start to move in a straight line from origin point with initial velocity its magnitude 8 meters per second, and the acceleration of motion after t second is given by the relation 3t minus 2. What is the required, my dear student? Find each of velocity of particle, this is number 1, and its displacement after 2 seconds from the starting of motion. The required, find each of velocity of particle and its displacement after what? 2 seconds. What you mean? T equals 2 from starting of motion. Look at the solution, my dear student. Since relation between acceleration and the time from the given is a equals 3t minus 2. What you mean of a? Acceleration. Good student. What is the required? Velocity. What you make, my dear student? Differentiation or integration? Integration. Why? Because we have acceleration, the required velocity. Then we make integration. Velocity integration of 3t minus 2. Therefore, my dear student, v equals 3 over 2 t square minus 2t plus c. What you mean c? Constant of integration. What is the value of c? By using substitution about v naught equal 8 to find c when t equals 0. Substitution about t equals 0 and v naught equals 8. Therefore, c equals what? Excellent student. C equals 8. What is the relation? Became the relation v equals 3 over 2 t squared minus 2t plus 8. This relation between velocity and the time. My dear student, the second required is displacement. What is the relation between displacement and velocity? Excellent student. Displacement integration of the velocity respect to time. What you do? Good student, we make integration respect to time t. At the first, we find the velocity when t equals 2. Substitution about t equals 2, therefore v equals 10 meter per second. When, my dear student, t equals 2, velocity equals 10 meter per second. Since, my dear student, v equals 3 over 2 t squared minus 2t plus 8. What is the x? X and student, we make integration respect to time t. Therefore, x equals integration of 3 over 2 t squared minus 2t plus 8 side bracket dt. Answer is half t power 3 minus 2 minus t squared plus 8t plus c dash. What is c dash? Constant of integration. What is the value of constant integration, my dear student? Substitution about t. X equals 0 when t equals 0. A particle when t equals 0 has no position vector. X equals 0. Therefore, c dash equals 0. What is the relation became? X is equals half t power 3 minus t2 or t squared plus 8t. My dear student, this is position vector or displacement. X equals half t power 3 minus t squared plus 8t. My dear student, this is position vector or displacement. X equals half t power 3 minus t squared plus 8t. When t equal to, by substitution, s is half 2 power 3 minus 2 power 2 plus 8 times 2 equals 16 meter. This is displacement when t equals 2. My dear student, look at another example. A particle moves in a straight line. The algebraic of its velocity is given as a function of time by the relation v equal 6t squared minus 24, where v is measured in particle reaches 72 meter per second. Then find magnitude of acceleration of particle when its velocity reaches 30 meter per second and the magnitude of displacement of particle during t belongs close to interval 1/4. My dear student, look at the solution. Look at, my dear student, we have relation v equal 6t squared minus 24. What is required? When the velocity of particle reaches 72 meter per second, therefore, my dear student, 6t squared minus 24 equals 72. Then find the value of t. 6t squared equals 96. What is the t squared? 16. What is the value of t? Positive or negative 4? We choose 4 only. Why? Because t not equal negative 4. T is positive or equal 0. In this case, t equals 4. My dear student, when the velocity of particle reaches 30 meter per second, by substitution in the same relation, 60 squared minus 24 equal 30. Therefore, 60 squared equal 54. What is the t squared? Equal 9. Therefore, t equal 3. When the velocity of particle reaches 30 meter per second, in this case t equals 3, but the previous t equals 4. Acceleration, we know that derivative of velocity respect to time t. In this case, my dear student, acceleration equals 12t. Substitution, A equals 36y because t equals 3. 12 times 3 equals 36 meter per second square. S equals integration from 1 to 4 v dt. By substitution integration, and s equals 8 equals s is 8. Integration from 1 to 4, velocity is relation between 6t squared minus 24 dt. What's the integration? 6t squared, 6t power 3 over 3 minus 24t. Therefore, 2t squared, 2t power 3 minus 24t. After that, substitution about 4 and 1. My dear student, answer is 54 meter. My dear student, by the end of the lesson, we know that integration of the vector function. Integration of the vector function means if we have acceleration and the required is velocity, we make integration about acceleration respect to time t. And if we have velocity and the required is position vector or distant or displacement. In this case, my dear student, we make integration velocity respect to time t. We know that A equal dv over dt, but velocity integration A respect to time t. And we know that v equal dx over dt. If we the required dx, we make integration velocity respect to time t. Then the first lesson and second lesson, this relation between integration and differentiation of the vector function. My dear student, by the end of the lesson, I am very happy to spend such time with you. Thank you.